0.
Hello everyone and welcome to part 4 of the MS Masterclass, Advanced NIST Hybrid Search of EI and MSMS Spectra, presented by James Little. Parts 1, 2, and 3 are now available on demand for you to view at any time. Parts 1 and 3 have been re-recorded for quality purposes. During this session, James will reference his website and the session handouts, both of which can be found in the Resources tab on the right-hand side of your screen. There you could also find the links to the other sessions in this series. If you haven't already, please go ahead and register for Part 5, which will be held on September 22nd at 10 a.m. Eastern Time. At the end of today's session, we will be addressing a few frequently asked questions that are relevant to today's content. However, please feel free to submit your own questions at any time through the Ask a Question chat box, and James will address them via email at the conclusion of the event. And now, I'll hand over to James to begin today's session.
Thank you very much, Ryan. So today we're doing the NIST hybrid search. It'll be part 4. But first, I ought to introduce myself because some of you might not have been to the first 3, but I'm James Little. I live in Kingsport, Tennessee. I'm a retired research fellow from Eastman Chemical Company. I had 42 years experience doing unknown identification, primarily by mass spectrometry in general, but I did NMR, infrared, and many other techniques. I'm now a consultant for MS Interpretation Services. It's a one-person company. I'm the sole proprietor and employee. I had a lot of specialties besides EI, GCMS, doing NIST type searches. I did LCMS, chemical ionization, accurate mass derivatization, just a whole list of techniques. But the central core of my job at Eastman was unknown identification, maybe if you want to call it reverse engineering of our products and other people's products. I worked at Eastman Chemical Company in Kingsport, and it's a very large plant. There's probably 14,500 employees total within Eastman Chemical at the 50 sites worldwide, but probably around, I don't keep up the numbers anymore, around 7,000 work on site. So it's a big plant, highly integrated. But more importantly, with regards to our topic, there's 50 mass specs networked worldwide. So there's a lot of mass specs at these remote locations, and we share data, we share information, and we're the resource center because we're the mass spectrometry expert center for the company. So we try to help people and share the data, and we create databases or libraries that we use to solve problems that you can do the NIST search on, our own personal user library. And we update them nightly. And that will be the topic of our 5th session. So if you want to hear how to create your own libraries and how to share them with people that you work with, then come to the 5th session. So as we mentioned before, we will be doing 5 of these. We've already done the first 3. But today we're doing the Advanced NIST Hybrid Search, and we'll finish up next week with the final part 5. I really need to stress the fact that to make this software work, all the NIST suites is great software, but you have to have all the settings done correctly. And if you don't, it will not work. So, and I don't want to bore you in the active demos. It just would take too long to walk through them. So I leave that as an exercise for you. So go download my handouts, and it has screenshots and information on how to set up these programs. And I even have the one for the 5th one, even though we haven't given it yet. It's all there. Google search a little mass spec and sailing. You'll bring me right to the top, or use the tabs as Ryan indicated within the webinar software. Here's a table of contents, and if you came to the first 3 sessions and looked at them, you'll see that I didn't have table of contents, but I started to see that all the different presentations were more complex than I would like, so I put a table of contents in 1, 2, 3, 4, and 5 with the slide number, and I hope that'll help you navigate and find things of interest to you, so you won't have to just go through the top to the bottom every time. There's a lot of help files for the NIST search and with the hybrid search and other things. And on my website, I found a lot of people that were willing to share how they were using the hybrid search, especially within NIST. So I put those resources on my website too, but there's also documentation that supports all of this. The Windows software this software is pretty much Windows compliant, just like most Windows applications. So all the common keys that you might use, might be a couple extra like F9, send a spectrum to MS interpreter, but in general, very Windows compliant. The other thing that we'll make use of today, you can do a search, let's say, and get in here, you get a fit of maybe 955, but you can resort any of the variables or any of the things that is calculated just by clicking on the top of the bar here, and it'll resort. And so I'll show you how to do that for hybrid searches versus identity searches. So we'll do that later. So let's talk about the program. The hybrid search is pretty much what it says. It generates a similarity score. The similarity score is pretty much what I showed you in session 1 and called it identity search. And it matches the fragments in the spectrum. But this program, in addition to that, looks at the neutral losses. So it looks at a loss spectrum, which I'll show you an example of, and calculates a fit for that. And then it merges those two values, and that's why it's called a hybrid search. It extends the scope of the library by including nearest neighbor. So it adds dimensionality to the resources you already have. So we've got these very large databases, and if it only varies by something added, let's say to the ring, then it will find that in a hybrid search and give you an idea of what it is. So it really increases the power of your libraries. But the success requires the presence of similar compounds, but really not a problem now. We have over 1 million compounds that you can buy between the Wiley and the NIST, and that's a very large library to work from and extend the capabilities using this hybrid search. The mass difference must be confined to a single region of a molecule and no significant alteration of fragmentation behavior. And that's, again, not really a severe problem. Just adding something to a structure many times changes the fragment ions where they appear, but if you look at the losses from the molecular ion, they might not be changed much at all. And the key part of making this work is what we call delta mass. It's the mass difference between your query, the unknown, and the library compound, and reflects the modification of the molecule. So for example, if you added a chlorine to an aromatic ring, chlorine weighs 35, you'd have to add a hydrogen to it, take off a hydrogen to put the chlorine on. So the delta mass would be 35 minus 1 equals 34. So you'd see the delta mass show up in the search results as the delta mass. It doesn't tell you it's chlorine, it just tells you it's 34. So you have to start understanding what delta masses are, and I'll help you with that later. So my personal experience with this hybrid search, I've used it in the last 2 years to search over 20,000 compounds. And what I can tell you daily, many times daily, because I do a lot of searches per day, is that I'm routinely amazed by the types of similar compounds with high match factors that you get with the hybrid search that you do not find with the identity search. Very frequently useful results, I said, are not obtained with these standard searches, but are with the hybrid search. It's very useful for finding similar model compounds, support for fragmentation mechanisms, and I think possible identification. I think the identification could be a very powerful tool. So let's show what a regular spectrum looks like for this aromatic compound we have here. You can see over here, you can see the molecular ion and some losses, and it's what a standard spectrum looks like. And when you do a search, it would say if you found these ions in your unknown and you found them in the database, then it would find it and you'd know what it is. So that's well and good. But it's even more powerful if you turn the spectrum in the top, and there's ways to do that for your user libraries, your old Wiley libraries, your old NIST libraries. You can turn them into a hybrid search library. And there's software to do that, and I'll show you how to do that. And then it turns the spectrum in. If you have the molecular ion, it would be 0. If you had a loss of 84, it'd be a minus 84 ion, which essentially generates a mass spectrum, which is a neutral loss spectrum. So first, the library does its standard search to do the top one, gives you a score, turns everything in your unknown into this loss search, and takes the whole database. The whole database has neutral loss spectra that are indexed. So you can create that with the software. So you can turn a standard fragmentation library into a neutral loss library and get these hybrid scores. So we pretty much have gone through the introduction now. I want to go to the actual demo now. So we need to switch screens here, see if I can do this pretty smoothly. I'll leave that right there. Go open the NIST library. Okay, so I hope you're seeing the NIST library now. I'm sure Ryan will let me know if there's a problem, but we should have it come into focus. And what I want to do first, remember, if you'll remember what we've done in the previous webinars, we always have our unknowns up in the top. We have the associated spectrum. If you had a structure, we don't here. It's an unknown. We're calling it an unknown. And at the bottom, you'll have the results for the search. And then the structures is the search. So if you use your if you use your up and down, you select the top one, make it blue, and then you can go down through things and see the possibilities of what it might be. In the middle, you essentially have the reflection of the top spectrum to the bottom so you can visually compare it. And head to tail is a good way to do that. So let's do an identity search first. So if you remember, every time you create settings, you want to save a configuration so you don't have to start all over again. So I've created one called Webinar EI, which is our identity search. And I just bring it back into focus, and then I say go to do the library search. See what we get. Okay, down in the bottom, you can see our best hit is 541. And if you remember before, I told you anything below 800 is probably indicates you don't have the exact identity of what you're looking for. So this probably indicates not so good information, that this is unfortunate, but don't give up yet. We're going to select the top one and step through them. And if you start looking, about the top 6 or so always have this ring with a bromine and a fluorine on it. So you say, well, that's very interesting. That must be more than just coincidental. So we could send that to MS Interpreter like we did in our last session with AMDIS, or actually in our structure program, and you can see what the ion is. So if you circle it here, you can see that we have the 187 ion is for that part of the molecule. So it's telling us something, but it really still hasn't told us what it is. So let's go back to the NIST search. Talk about parameters for a minute. If you remember, you have to go up and set up the analysis of the parameters to get the right search. So I had to search one for EI normal. So I did all of that. You have to go through the handout and make sure all of these are set up properly. And after I did that, I said File, Save Configuration. I did the same thing for the hybrid search. And when I got through, I created a webinar called Webinar Hybrid. And so let's just bring it back into focus so we can do a hybrid search, okay? So nothing really changed much that you can see here, but I do want to mention as we go through here, there's something called tools up here. And this is where you index your library. Let's say you had an old copy of this library, you had an old copy of the Wiley, you don't have the best and newest copy of it. You can re-index your EI hybrid for all of your libraries to turn them into hybrid searchable libraries. It just creates additional index files. So you might have to do that for yourself. And again, that's very well documented. All right, so we're going to do a hybrid search now. So let's just do the same thing and say go. Searching about 1 million hybrids spectra. It's pretty fast. It's actually doing 2 searches here. And let's take a look at some things first, because we want to talk about the precursor here. It tells you what it thinks it is. Someone has to decide what the molecular ion is, because you have to subtract things from it to get the neutral loss. And the software thinks it's 313. And being a mass spectrometrist, I agree with it. It looks like 313. So I'm looking up here at the top. It says the hybrid precursor is 313. It also tries to tell you at the bottom. If you look at the bottom right corner, it's a very important parameter. So you want to make sure you're searching what you think. If you don't have the correct molecular weight, you will not get good hybrid search results. Let me say it one more time. If you do not have this value properly accessed through the software, you will not get the result. So what do? Well, you can go up and change it. So you go up to your settings, and right over here, you'd see where you had the hybrid, you would say it's not in the spectrum anymore and put in your value. So we'll talk a little bit more. How do you get good molecular weight information? We'll talk about that later, but it's important to know if it's not done correctly, the results will not make any sense. So let's look at the results of our hybrid search. We're going down to the bottom of the screen. We can see a match factor of 908. Well, that's a lot better than the 541 we had before. And if you step down to the next one, we're already below 800. So I'm not too interested. I'm very interested in this top fit. So what is it telling me? Well, I told you the delta mass is very important. It's 18 here. If it's not in your software as it comes out of the box, you need to right click in the window, go to properties, and then you select that. You can select that. And also we're going to select O match, which we'll talk about later. You need to have O match and you have to have delta mass. Okay, so we've got the window all set up, and you can step through them again, like using your arrow keys. But like I said, the next one down is 781. not very useful. So we're talking mainly about the first one. Well, so you got to start thinking about, well, what does 18 mean? Well, we knew in the substructure a minute ago that it had fluorine. So what I really think would be the best guess is if you look at the structure down here, one of these hydrogens is no longer there, and you put a fluorine on the ring. So I'm pretty sure from these results that that's a really good candidate for an identification. So you have to decide where it might be. Well, that's not really easy to do with mass spec. The positional isomers are not so readily determined in most cases by mass spec. But I'm with high confidence, I believe that one of these hydrogens has been replaced by a fluorine, and the bromine could not be in the position it says either. But I think there's a bromine and a fluorine on this ring. I think that's that's almost certain. And so that's really somewhat the essence of the hybrid search, is that you do the search and you look at the delta mass. You just got to figure out what these delta masses are. In this case, we took off a hydrogen, which weighs 1. We put on a fluorine that weighs 19. So the delta mass is 18. So let me look at my list here to make sure before we go back out of the software that we've done everything we want to do. Pretty much it. So I think I'll go back to the PowerPoint, and I hope get back to the slide. All right. I hope Ryan will tell me if we're not there, but I think we are. So we need to mentally merge the information of the hybrid and simple identity EI search. So we've got all this information. So the user has to do this. There's really not part of the program that says, oh, this is it, but you have to use your own instincts to determine this. So the unknown spectrum looks like this. It looks like it weighs 313. And if you knew mass spec well, you'd know that that has at least has 1 bromine isotope. And here's our hybrid best result. So it tells us again, it's there, but there's a bromine missing from this because this is 18 higher in molecular weight. We know from the simple results that it has to have this part of the molecule. And so we propose our unknown as having a fluorine and a bromine on the ring somewhere, and go talk to our customer and see if it makes sense. I want to go back to one thing for the software because I missed one very critical point. I showed you before that we could do an identity search here first, but you don't have to do that because part of the hybrid search is the identity search. All you have to do is resort by this thing called O-match, and that means original match or the identity match. And you just click on it, and you'll get the same results we saw before. You'll see the best hit was this brominated fluorinated compound that we thought was indicative of this aromatic ring up to the benzyl group here. So you don't have to do it, search it again, just sort it again. So it really doesn't cost you a lot of time. The search is about the same amount of time, but go back and forth between the match, which is the hybrid, 908, and then the O match. And then you always have to pay it, when you look up the hybrid, pay attention to your delta mass and see if it makes some sense. And I'll talk about some of the possibilities for figuring out what the delta mass is. If you had accurate mass, that would be good. You'd tell that by that, the molecular formula includes 1 more fluorine, but you don't have to have it. You can have nominal mass. So let's go back to the PowerPoint. All right. So we've kind of mentally merged that. Let me get back to the page display. Okay. So we pretty much did this. I'm going to step through that real quickly and go to the next slide. So let's take a closer look at that middle display. I didn't want to talk about that mirror display we normally get because I found it very confusing when I first started using a hybrid search. I guess I don't realize why now, but I did. And let me tell you what it means. We have our unknown on the top. See it here. Looks like it weighs 313. The spectrum in the bottom in black or in gray is the original spectrum. If that ion would have been shifted by the presence of the fluorine on the ring, it will be shifted into a color. So I showed these, it doesn't show deltas on your curve, but that means delta mass. And I wanted to show you, so this gray one's been shifted to a color there, and all along the spectrum. So the ion that has been shifted is in color on the bottom, the original spectrum is in gray on the bottom. And so you just have to get used to looking at this, and if you can just tell your mind to ignore the gray peaks, you'd be much better off, and that takes a little practice to do. So what you can do when you're first doing it is you can tell the middle display, if you go down and right click anywhere in here with the right mouse button and say neutral loss display, it brings up the neutral loss of the best unknown, the one you have selected with the arrow keys on the keyboard, which would have been the top one over a 900 fit. And then the top is the unknown. And you can see now when it's in neutral loss mode, they line up pretty well because it's telling there's a zero loss from this molecular ion, which is 18 higher than the other one, but the neutral loss is essentially the spectrum that starts at 0 and goes to minus numbers, and that's what it's searching. And what it does is it merges the two. But I would highly suggest, after you get used to using the hybrid search, use the mirrored search with the deltas. And I don't think you need to go to the neutral loss, but it might be a little crutch you can lean on when you first start, because after you get used to it, after a while you'll get so you just ignore the gray and step right to the colored ions. So it's a real clever way to show a display. I don't think I would have ever thought about it. So I can't stress enough that the hybrid search needs to have a molecular ion or molecular weight known to work. And about 10 to 15% of the things in the Wiley and the NIST databases don't have molecular ions. So that tells you you've got maybe a 10% probability that you'll have to figure out what it is. Well, how do you do that? You can let the program determine automatically, and I showed you in the display that after the search, watch those corners and see what it thinks it is and see if you like it. If it doesn't make sense to you, you need to figure out what it is. So let it determine automatically. And NIST is working very hard to find out better artificial intelligence type methods for determining it for you. You can use it, you can look at logical losses from yourself. Certain ions are not allowed in mass spectra, like a loss of 9 is not allowed, a 15 is allowed, a 18 is allowed, a loss of 5 is not allowed. You need to become a mass spec interpreter. So that will take a little bit of finesse. Chemical ionization. If you can't get a molecular ion, you add gas to your source and tighten the source up a little bit, and now molecule reactions occur between the reagent gas. So the reagent gas gets hit by the electron beam, turns into a protonated phase, like a plasma. And then those plasma ions, because they absorb the energy, and really your neutrals are still there from your compound, they'll pick up a proton, they'll pick up an ammonia, etc., depending on which reagent gas you use, and you'll determine the molecular weight. I can't imagine a laboratory that could not do chemical ionization that really wanted to do true unknowns. It's a critical skill. NIST software has a lot of different things to do it, but I told you, if you can't figure out what it is, after you figure out what it is, and it's not what the NIST program picked automatically, you'll need to go in the settings and set those up in research. So they also have some software within the program. Let's look at that, talk about it a little bit. Okay, after critical qualifier, library searching an unknown spectrum uses the hits. It looks at the hit list from the similarity search and a rule-based system to propose molecular weight and substructural information. And if you do that, this would, if you do structure, substructure identification here and select to that, that's what's done after the search. It populates this window based on the search results. So you can't get useful data until you do the search. But if you do, it tells you a lot. It tells you substructures are present, it tells you the probability of isotopes like chlorine being present, but most importantly, it gives you an indication of the molecular weight. It says it thinks there's a 97% chance this weighs 313 and almost a 0% chance that it weighs 312. Another way is to say the molecular estimation of the unknown, and this is another algorithm, but it doesn't require you to search before you do it. It tells you right here, it says 313 from the hit list. 313. I guess this one actually is from the hit list also. Maybe, I'm not quite sure about that, but use these tools. The two different ways. It says the simple algorithm does not use the hit list information, but the more complex one does. So the simple algorithm does not, and this one does from the hit list. So it actually has both values here. But it all looks good. This all is telling you it weighs 313. So very useful. So I wanted to show you again, just to remind you again, when you get through, if you want to see what happened, you always want to keep up with what the search is doing. If you go to the top window up here, it'll show that in this case, the precursor was 405. This was another unknown. It's echoed in the bottom down here at the bottom of the display. So it's echoed at here at 3. It's echoed at 5. Also 4 tells you the type of search you did. You did a hybrid. It also tells you the next search you're going to do if you don't change the parameters. If you click the go button again, it's going to do another hybrid. It also, if you click this little icon up here that looks like a little magnifying glass, it opens here and tells you what it actually did too, with even more detail. It shows you the libraries and what other parameters you might have set. So the software is really trying to tell you what it's doing, so pay attention to it. That's what I told you. Okay, delta mass table. What I've done, I've looked at 20,000 things over the last 2 years, and I've started creating, I wish I'd started the first. I created a table that when you get a delta mass value, what's it trying to tell you? Like if you get a certain thing like a 10 in the molecular ion region, or a delta mass on the search is 10, it's trying to tell you that there's an ethoxy on the aromatic ring is group element 1 and group 2, and I'll show that it's added chlorine. So it does differences. It says it's got an ethoxy and it's been replaced by something. So I tried to create these. I need to work more on this delta table, because I think it would be really handy to have some values that you use. So I've created these, and it could be plus or minus depending on the species present or absent. It's really just a delta. And I continually update as I find better ways to represent this as time permits. And it's under construction all the time, but it's on my website with the different resources we had. But to visualize this, let's just look at some very simple examples. These are some simple small molecular weight compounds to illustrate the types of substructural information you get from delta mass. So let's look at the ones right here in the center. If you take this compound and you let it pick up a carbon and 2 fluorines, it'll have a delta mass of 50. It'll tell you when this compound shows a 50 gain, then you probably added a fluorine has gone up to a CF3 group. Well, that's good, but look here, if you take a benzene ring or something with just one aromatic ring and you form a naphthalene type system, it also gives you a delta 50. So there is some redundancy here. I show some 58s that were the same here, so 2s that are the same here for 2 different type structures, but you have to look at all the information, look at the fragmentation. And of course, these substructures can be part of a much larger molecule. I was just trying to give you an idea of what happens to change this delta mass. Note, it's kind of like a nitrogen rule. If you ever looked at mass spectrometry and learned your basic interpretation, there's something called the nitrogen rule. A compound will have an odd molecular weight if it has an odd number of nitrogens. If it has an even number of nitrogens, it'll have an even molecular weight. Well, there's something kind of like this. If you look at this bottom here, where we have a benzene ring, and now we've gone to a naphthalene with a nitrogen in it, it's changed the number of nitrogens, and the delta mass will be odd. So if you go from a delta mass that changes to something odd, that means it likely added a nitrogen somehow. Here's another delta mass of 1 where a benzene has gone to a pyridine ring. That would also give you a delta mass of 1 and tell you that there's a nitrogen present or changed. Okay, look at your isotope ratios, and your accurate mass are helpful with redundancies to try to decide which is logical when you have more than one compound that could have a delta mass. So what are some final things to consider when you're using the hybrid search for unknown identification? Well, do accurate mass data. If you have an accurate mass instrument, we have at Eastman now, we have a GC Orbitrap, wonderful tool for determining molecular formulas by chemical ionization when they don't have molecular ions, and just by EI, very valuable. Chemical ionization, there's an article on my webpage that talks a lot about chemical ionization. It's a good book referenced in there. Make sure you know how to do it, and it will be you'll very much appreciate it when you're doing just general work, not even hybrid, but it's just so powerful to know the molecular weight of something with accuracy. Sample history, talk to your chemist, talk to your engineer, talk to anyone that knows where the sample came from, because that'll lead to insight in what it might be. Isotope ratios, they can be modeled in MS Interpreter, so as we talked about in, I think, session 2. Logical fragments, using MS Interpreter, it shows you fragments, so use that information to support whatever you propose to help you identify. You never look at a sample within a GCMS run by itself. You might have 50 components in there, and they're all probably, in most cases, related to one another. So you can look at other things that the library knows, and then trying to use that to determine the class of compounds to determine what your unknown is. So always look at it in the context of the sample you're running in the GCMS analysis. Always go to your customer, talk to them, find out what they know about it. Use other techniques. The only problem is a lot of times we're looking at trace components or smaller components, so it's hard to do NMR and IR, but if they're major components like a 50-50 mix, go talk to the NMR people, go talk to the infrared people. Elemental analysis tell you the elements that are present. In my paper about chemical ionization, you talk about deuterium exchange CI. You can count the number of exchangeable protons. You can derivatize things. I've got a whole paper on derivatization. in my on my website. So that's pretty much what you need to do. But let's talk a little bit about MSMS hybrid searches. The NIST sells a group of spectra that are in MSMS mode, and it's a very large group. And the hybrid search can work very well for these. Maybe the hits might not be as high, but the things toward the top of the list greatly expand the use of these databases also. So you should do LC MSMS Tandem. It's very good. They come in hybrid format, ready to go, and they're very good for identifications not in the compounds, not in the library, just like the other. There is some additional software for doing MSMS. So if you go up to the tab here, you'll see when you're setting up your parameters, you can tell it to limit the search by a mass window, because if you have accurate mass data, it'll do the search by accurate mass, and you can limit the error that's associated with that to something you think is reproducible on your instrument. It'll greatly narrow the possibilities. The other thing is, you'll notice they've added a new little icon up here. It looks like a separate, like a funnel to me, like a filter funnel. And I guess that's what they mean, is a filter funnel. So what happens is you do the searches, but then after the search, you can go in and just change these filter settings. It doesn't do another search. It just limits the results of your search you're being shown. So you can just play with these. You might say, well, I did it on an ion trap. I know it's a M+H ion. I know it's a sodium adduct. So you can limit the searches there and get rid of some of the too many hits. It narrows it down for you. So this is something that's just been added recently. Very valuable. The Wiley tandem libraries. Wiley has two different ones. They have one of about 12,000 entries here, and they also have one of about 2,000. Again, some very valuable things when you're trying to identify an unknown. So I highly suggest, if you do a lot of LC-MSMS, I would use library searches. And on top of that, I would create my own MSMS libraries in the proper format. The only limit right now is that these are not currently supported in hybrid format. And there is a way you can do it for some of them, but it's not so straightforward. But hopefully in the future, I believe Wiley will add it to their standard delivery of the software. So I don't think it'll be a long-term limitation, but you can create your own libraries in hybrid format too from the get-go. Well, there is software to do it, and maybe you ought to contact me or someone else. Maybe I can give you some ideas, but it's not as straightforward. There's no pull-down menu that says convert my library to hybrid format for MSMS. It only does it for EI. So it's a little restricted in that regard right now as regard to user libraries and the Wiley database. The final thing we have here, if you hover over any of these, you'll see that every one of these links goes to the internet somewhere, either my site or someone else's site. So there's a lot of information here for doing that. So I'll leave that with you there. So I hope you'll enjoy those resources. Acknowledgements. Wiley webinar production. I would have never done this without their help. They encouraged me and gave me the skills that I needed to do this. We struggled here and there, but I think we're getting to the end, and I think the product will be what we want it to be. So I wanted to thank Ryan and Kristen for all their very hard work in helping me learn how to do this process. Technical advice, David Sparkman is from, he also works for NIST. He's also a professor at the University of the Pacific, and he teaches some very good classes on interpretation of EI GCMS data. And then I'll always have to mention Steve Stein. There's just so many people that work at NIST, and Steve is the leader of this effort. And he has so many talented people that always have original ideas on how to do things, and they turn them into things that are products that make the libraries more powerful. Their main product is the library. So this other thing, a lot of the software was developed for them to do their job in confirming that it's good quality data to put in the library. But they do share the programs with us, and I greatly appreciate that. So that's pretty much to the end. I'll give it back to you, Ryan. Are you still there with me?
I'm still here, and thank you for running through that with us, and thank you for the acknowledgements. With these last couple minutes, I'd like to run through a couple of our frequently asked questions. And the first one is, how well do you think the hybrid search will work for unknowns?
Ryan, how are we doing on time? I just want to be careful with time. Are we okay to take a couple of minutes here so it's not critical or anything?
We're okay. We're 43 minutes past the hour.
Okay, very good, very good. So I've mainly used it I do confirmation work, quality work for Wiley and the NIST, and it's wonderful for doing that because it just brings up examples that make me feel good that the new spectrum is the one that I want to say is good or not to go in the library. But I really feel if you got the delta masses, you did chemical ionization, it doesn't really cost you any more to do the search because you can resort after you get through. I would, if I was doing straight identification work now, I would be very, very excited because I think it's just such a big quantum leap in capabilities. So I would be surprised if you couldn't use it in your work.
Can I use the hybrid search with my user library and with older versions of the Wiley and NIST?
If they're EI, you can. All you have to do is do that little pull down under the tools, and anything that's not capitalized says it hasn't been formed into a hybrid library. You just select it and run it, and within 30 seconds to 40 seconds, you'll have all the libraries be converted to hybrid format. The rub comes with the MSMS. It doesn't have a pull down for the Tandem libraries. There are some ways to do it, and it works on some and not on the others. So we need to do a little bit more work, I think, in making that a little easier to use. I think Wiley could make theirs into a Tandem pretty easy. And that also, that search that I showed you with the funnel works on tags, certain tags. So it's good to do that also, to use the tags. And so they need to put some tags in that make it easier to do the hybrid search. But that's all doable. So I think that'll change. And then, of course, the user libraries are another issue, too. You'll have to make sure that you create them in the correct format.
Is it difficult to obtain molecular weight information by chemical ionization to support hybrid searches?
No, not really. I have a paper on the website. The only thing is I like to switch between 4 or 5 different chemical ionization reagents. And we built a manifold so we could just flip a switch, or rotate a switch, and it changes the different gases in the source. We like to use ammonia to use as our gas. And you think, well, ammonia, that's not really a good choice. That's pretty nasty stuff, isn't it? Well, yes and no. If you open it and take a whiff of it up your nose, it's pretty nasty stuff. But if you keep it contained like it should be, and you run chemical ionization, if you use isobutane as your reagent gas, you get a lot of hydrocarbon buildup. You can imagine if you put something in an electron beam, you hit it, you get some carbon built up. It'll make your source dirtier. The response will go down with time. But think about it, put ammonia in there, and it kind of cleans the source. So the ammonia, it's hard on your nose, it's hard on some of the gaskets if you don't use the proper gaskets in the manifold, but your source likes it because it actually cleans it up a little bit.
Okay, I'm going to make this our last question. Does the NIST search do a good job of guessing the molecular weight?
It actually does a pretty good job. Between those software tips that I showed you about the programs you can go after the search and the simple algorithm, but it's not perfect because I know it's not perfect because Steve and his team are working on better ways. If it was perfect, they wouldn't be working on it. So I know that they're really excited about the hybrid search and they want to make it better and better. And they think that's a critical part in doing it, is making sure you get good molecular weight information before you go into the search. And if you can do that automatically, it's even better.
Okay, and I'd like to take this time to remind everybody viewing this session that you may still ask a question and we could address it offline via email. I'd like to thank you, James, for sticking with us this long. This is part 4 of our 5-part masterclass. Part 5 will be presented on Tuesday, September 22nd at 10 a.m. Eastern Time. If you haven't already registered, please go ahead and do so. It is in your resources tab for easy access. And I'll pass it back to you, James, for some concluding statements.
When you do identifications, the library, especially in identity mode, makes it so easy. You push a button, you get results. But you got to be careful. Certain compounds have the same mass spectrum very close, but they might have different molecular formula. And so you have to be careful it makes sense with the sample history, with your customer. So you need to think about it before you just report it out. You can give it out, but you might say tentative until we have a conversation. And then after you have the conversation, you might need to buy a sample. You might need to prepare a small amount of it. We do a lot of preparation in the lab where we just mix up something in a reagent vial and heat it on a block and get a mixture that's enriched in it. That's good enough. We've got chromatography to separate things. We don't need to do preparative analysis we just want to know by a known reaction, it matches the retention time and the chemistry matches the structure. So that makes sense. So I just really want to tell you that does look easy. You can push the button and get the results, but customers realize after a while, if you're giving them bad results, then they'll lose confidence in you. So make sure that you can keep the confidence of your customers by working together as a team. So that's really all I have to say, Ryan. So I really appreciate your help today in moderating the session. So we ready to call it quits?
We are. Thank you again.
Good evening.